Bismillahirrahmanirrahim. Assalamu alaikum. Uh, Today we'll be doing our lecture number 4A, property of the pure substance, and yes, we'll be doing the numerical side of it. Today we'll be also introducing the one of the new concept, which is called as interpolation. We go to the interpolation. What is interpolation? Let's read out the question first. The questions here determine the temperature and quality if defined um, for the water at the pressure of 300 kPa and each of the following volume. So we have been given two different properties. One is actually the pressure and one is actually the specific volume. So what we have to do, like in these one, we have to find the temperature and quality if it is defined. Quality is only and only defined when we are inside the vapor dome. So if we are outside the vapor dome, which is actually superheated region or a compressed region, the quality X is not defined. The quality is only and only defined when we are inside the vapor dome. So obviously it's like if we are inside the vapor dome, so what would be the quality of the system, quality of this of the water, sorry. So determine the temperature and quality defined for 300 kPa and the specific volume. So let's read it out, the first one, or let's do the first one. So we have got pressure we have got a pressure of 300 kPa and a volume of 0.5 cubic meter per kg. Now, if you go to the steam table, so obviously there would be a steam table of temperature as well, and there would be steam table of pressure. So pressure is 300 kPa, which come up as 0.3 megapascal. If you can just check the corresponding temperature at 0.3 megapascal, it will come up as 133.53 degrees centigrade, and the volume, which are two different volume given, it is volume of Vf and volume Vg over here. So volume Vf is equal to 0.001072 and volume Vg is equal to 0.60579. Our given volume is 0.5 cubic meter per kg. That means like our given volume is greater than Vf, and obviously if you can look at the value of Vg, so our given volume is less than Vg now. So that would mean like we are inside the vapor dome. So if we are inside the vapor dome, so that simply say like the quality would be defined now. So let's go to the blank page, and then let's say for the value of quality, V is equal to Vf, and obviously I would be looking at not specific V, and that would be actually small v. V would be equal to Vf plus X, Vfg. Let me write it down then. G, and that's what actually our mathematical equation should look like. Set math, and yes, Vfg. So let's see, we will be having this one now. So V is equal to V plus X Vfg. So in this case, X is equal to V minus V divided by Vg minus V. So just solve this one, and you would be having a quality which would be equal to X would be equal to 0.825. That was a very simple one, and obviously let's move forward to the other bit of it, and that is actually the second part. Now looking at the second part, if I would say the specific volume is same, the pressure is same, while the specific volume is now changed to 1.0 cubic meter per kg. Going back, obviously you have noticed that 1.0, if we have got a 1.0 cubic meter per kg volume, so this 1.0 is definitely greater than the 0.60579, which means like we are in a superheated region. So I would rub it out first thing, these things. So let's move forward to the superheated table. So in a superheated table, just look at it, the superheated table first, and then obviously then we will looking at the pressure, looking at the our own problem. Um, there are two different properties given. One is actually the pressure, and one is the temperature. So the pressure is given in a column form, which is actually there, and the temperature is given in the row form, which is somewhere here. You can find different steam table, you can find different steam table of different style. There might be like both of them would be in a row, or might be both of them in a column, but the main feature would be the pressure and temperature would be independent of each other. You can also find different other value in the steam table as well. You can look at this one, you can find the volume, you can find the enthalpy, and you can find the entropy in this table as well. Okay, how do we read it? Just find the temperature, sorry, pressure, which is equal to 0.3 megapascal. If you can check this temperature, and if you remember just now, it was 133.53 is our saturation temperature. Now, look at the other bit. We are interested in the volume of it, which is 0.3, corresponding to 0.3. We are looking at the volume, which is equal to 1.0 cubic meter per g. Now go to the column, go to the row wise, and obviously looking at the volume, which would be equal to 1.0 itself. We have got a volume of 0.9536. We have got a volume of 1.0315, but we do not have got a volume of 1.0. Just checking the temperature up there. So we have got a volume of 0.9 somewhere in the 350, and we have got a volume of 1.10315 at the temperature of 450, 400 degrees centigrade. So what actually is obvious over here, let me take a snapshot of this one so we can have another one. So taking the snapshot, and let me paste the snapshot over here. So what we have got again over here is we have got a volume of 0.9, which is at corresponding to 350 degrees centigrade. We have got a volume of 1.0315, which is corresponding to 400 degrees centigrade, but we do not have got a temperature which correspond to our own volume of 1.0, which also mean, like, if I can draw a little bit over here, which also mean, like, if I draw it on a temperature and volume diagram. So what we have got here is I've got a volume of 0.9536 corresponding to 350 degrees centigrade, and I have got a volume of 1.0315 corresponding to 400 degrees centigrade. Sorry for this bit. So take my temperature up there. Okay, but I do not have got a temperature which correspond to my own volume of 1.0. So I do not have got a temperature, which is temperature is not. So how do we solve it? If you can look at what your previous knowledge would be in my own, I would say, like, thought. Your previous knowledge is like, okay, we have got a temperature of 350 and we have got a temperature of 400, and volume, our volume is somewhere in between them two, in between, I'm saying. So that would mean, like, just plus 0.9536 plus 1.0315 divided by 2 would be equal to, should be equal to 3.350 plus 400 divided by 2. That means like you can take the average of the two temperature and you can find it. But the average of the temperature would come up as 375, while if you can even average this one divided by 2 actually, so it would not come as 1.0. So what you would be doing, you would be taking again and again average and average, and then obviously it will not be there. There is another method, we call it as interpolation. Let's see, let's check it, and that's it. I'm just drawing a straight line, I'm sorry for that. That should look like a straight line. So this is called as interpolation. And what is interpolation? Interpolation mean like interpolating a value between two values. That mean like we have got 350, we have got 400, and we have got a value which would be somewhere between 350 and 400. So that's why we are interpolating the value now. So how do we interpolate it? So this method is called as linear interpolation. What we are assuming that as the temperature go from 350 to 400, the volume would be going from 0.9536 to 1.03115, and them both actually temperature and volume, they are actually moving in a straight line. This is what actually our assumption is, and that assumption is would be valid for all our engineering courses, even if I'm talking about the power plant in a final year as well. So this is what we call it as a linear interpolation. So remember, in linear interpolation, if I would say like interpolation, and remember the graph which actually you can see on my screen now. So it does look like a straight line actually, and a straight line can be found with the straight line slope. If you remember, straight line slope is equal to y2 minus y1 divided by x2 minus x1. So something like this. And if you can just go for the our own value, so that would be m would be equal to what would be y2 t2 minus t1 divided by x2 minus, sorry, not x2, v2 minus. So that would be the slope of, let's suppose slope of these two lines from 400 to 350. And also I can have another slope which would be somewhere this one actually. So that would be actually, so if I would say like my slope m2 would be equal to t, which we need to be find out, minus t1 divided by v, which is actually 1.0 minus v1, which is actually somewhere this one. That's right. So in other words, if I would just say like 2 of the slope of the straight line would be equal, so that means like t2 minus t1 divided by v2 minus v1 should be equal to t, which need to be found out, minus t1 divided by 1.0, which is given, minus v1. You can call it, if I would say like if you are a little bit confused, call it t naught, and if I would say like this volume, call it v naught. So that means like v naught would be equal to 1.0. But anyway, you can actually have any I would say like abbreviation for you like. So in this case, 305 T2 is equal to 450. Sorry, 400 minus 350 divided by 1.0315 minus 0.9536 should be equal to t naught, which need to be find out, not mean like need to be find out, I would say minus T1 was actually 350 divided by V naught, which was 1.0, minus V1, which was equal to 0.9536. And let me solve this one, and that would be T naught, or if I was like T required, would be equal to. So the temperature I have calculated